Okay, so the first chapter is physics and physical measurement. This chapter is pertaining to information related to the data analysis question in paper 2 and also a few MCQs. So some of the important points are mentioned here in the chapter. A lot of the information here should be known by the students beforehand if they've gone through IGCSE. So a lot of them you don't have to cover in depth. But yeah, if the students need some reinforcement in those sections, you can probably go through them again. The more important ones which you need to emphasize on are these. Firstly, 1.1.2, state the ranges of magnitudes of distances, masses and times that occur in the universe from smallest to greatest. So if you turn to your notes, page 2, there's a table here that the students basically need to memorize. Because in the exam there will be MCQ questions which will randomly ask you any one of these ranges of magnitudes. So the student needs to memorize the entire table. 1.1.4, estimate the approximate values of everyday quantities to one or two significant figures. So this is making a calculation based on an estimate. You just have to estimate the calculation to the nearest power of 10. You don't really need to calculate it accurately. For example, over here you have an example 16 times 5280 times 12 times 12 times 12. So then you will approximate these to their nearest powers of 10. You have 2 times 10 to the power 1, 5 times 10 to the power 3 times 1 times 10 to the power 1, 1 times 10 to the power 1 and 1 times 10 to the power 1. So then you multiply the numbers here. You get 10 multiplied with 10 to the power of 4, 5, 6, 7. 10 to the power 7 and your approximation would be 10 to the power 8. So this is an estimate of this calculation. So again, if you check this with the calculated answer is 1.46 times 10 to the power 8. So therefore this is a fair approximation to the actual answer. The next salient topic is 1.2.2. 1.2.2 is distinguishing between fundamental and derived units and give examples of derived units. So you can probably first ask if the students are familiar with most of the units of various quantities, and then see if they can derive it. For example, force is measured in newtons. So if they need to derive this in fundamental units, so they need to write newtons in fundamental units. What they can do is force can be written as mass times acceleration from Newton's second law. Mass is measured in kilograms and acceleration is measured in meters per second square. So therefore the units of force, Newton, here can be written as kg meter per second square. So they should be able to do this for most of the quantities as well. And this is a technique which will not help them directly. This is not gonna be tested directly in the exams, but using fundamental units can be a very useful tool in checking your answers or actually going through calculations in examinations. I always encourage my students to use units, and especially derived units into fundamental units, in order to check their calculations, in order to work through the answers in all the questions. So this can be a very useful tool. Okay, next we have state units in the accepted standard international format. Students should, okay, so basically this is just a housekeeping measure. For example, a student should not be writing this anymore as they might have done previously in previous levels. The standard way of writing this is meters second minus square. So this is a standard way of writing. They should probably avoid using this kind of notation. 1.2.6, describe and give examples of random and systematic errors. So students should be able to define random and systematic errors and they should also be able to determine that systematic errors are caused by calibration issues, wrong techniques, etc. And they can actually be eliminated if they are identified, whereas random errors are caused due to human error or mechanical vibration, electrical noise, etc. etc. Random errors cannot be eliminated, but they can be reduced. So they should know the methods of reducing random error as well. For example, that would come, I think, in 1.2.8. Yeah. Explain how the effects of random errors may be reduced. So for example, if you have a pendulum and you want to reduce the random error, if you're measuring the time period of a pendulum, so what can be done to reduce that random error? There was an MCQ question previously in IB. One of the options was taking repeated measurements. So you take 10 time periods and you repeat that a few times. But that would not reduce your random error because the amount of reaction time would still be the same. So the actual correct answer for this is increasing the number of time periods that you measure the time period for. So you take a few more oscillations. For example, if you were measuring 10 oscillations, you measure 30 oscillations, and then you divide the 30 oscillations, divide the time taken for the 30 oscillations by 30 in order to get the time period. So that way you reduce the error caused by the human error which when you were pressing the stopwatch. So stuff like that, you need to basically let them know different methods of reducing random error. That's 1.2.8. 1.2.10 says state uncertainties as absolute, fractional and percentage uncertainties, and also determine uncertainties in the results. So you need to, this is one of the most important points of this chapter, which will pretty much always be tested in the data analysis question. So if you turn to page, so if you turn to page 8 of your notes, there's a table here which very concisely sums up all the information that the students need to know. So for example, if you have a reading like this, 9.8 times 9.8 plus minus 0.2 meters. So a measurement like this, you can actually determine a lot of information. Firstly, the limit of reading. The limit of reading would be the smallest limit to which you can read. Now over here you see that it's been measured to 1 decimal place of accuracy. So whatever instrument you're using to measure this, the limit of reading would be 0.1 meter. Okay? And the uncertainty in this reading is going to be half of the limit of reading. Uncertainty 0.05. Remember, uncertainty is always written in one significant figure, no more. Okay, but from this reading, we know that the uncertainty is actually 0.2 meters. So therefore, the absolute uncertainty is going to be 0.2 meters. Okay. Now, the relative uncertainty is the absolute uncertainty divided by the value itself. So the relative uncertainty will be 0.2 divided by 9.8. So that is again 0.002. Notice that again we've written the uncertainty to one significant figure. Percentage uncertainty is simply relative uncertainty like represented in percentage form. So that will be 0.02 multiplied by 100% be 2%. So these are the things they need to know. Now when you're calculating uncertainty for some calculation, this will be determining uncertainties in results 1.2.11. So whenever you're adding quantities, you are adding up the absolute uncertainties over here, and whenever you're multiplying quantities, you're adding up the relative uncertainties. So you need to make sure that they understand this and they should be able to use these two results in order to calculate the uncertainties in any kind of a result. And the best way to go about this is to discuss a data analysis question from the ID paper. Again, 1.2.12 says identifying uncertainties as error bars in graphs. This is again used in the data analysis graphical question, and you should also make sure that they understand how to calculate the width of the error bars, and also that the error bar width may change, because for example in some questions they have a fixed relative uncertainty, but the absolute uncertainty will increase as the size of the reading increases. So therefore the error bars goes on increasing as well. So you need to give an example of this sort. Again, pick a question from the data analysis question and I basically demonstrate this. State random uncertainty as an uncertainty range and represent it graphically as an error bar. So return to page. Yeah, so page 13 basically sums up 1.2.13 and 1.1.14. Basically these are the two topics which cover using error bars in graphs. So over here there's a short description of how graphs can be used and how you should be using this graphical data in your exam. So for example, if you have a set of points and you need to calculate, you first would probably be asked to calculate the error bars and then calculate the uncertainty range. Now uncertainty range, for example, if you are talking about the uncertainty range in the y-intercept, so if you have a few points, you need to let them know firstly at the points you will be drawing error bars. You will have a few error bars. Okay. Now, in order to calculate the uncertainty range, what the students will always be expected to do is draw a line of the maximum gradient, draw a line of the minimum gradient. So the maximum gradient would be from the top of the error bar here to the bottom of the error bar there. And the minimum gradient, for example, will be from the bottom here to the top here, and a line of best fit which is somewhere in between. So the line of best fit would give you an approximate reading of the value, and the two lines which of maximum and minimum gradient can actually give you the range of the error in the y-intercept. You can also use this method to find the range of uncertainty in the gradient. So for that, the students will be expected to calculate the gradient of both the line of maximum gradient and minimum gradient, and then calculate the range, divide that range by 2, and that becomes your answer. So you'll probably write your answer as the reading plus minus half the range that you found out over here. So you need to elaborate this to the students as well. Right. This will become clearer again, as I mentioned before, when you discuss this a data analysis question with the students. These are pretty much the most salient features of this topic. 1.3 is basically a revision of vectors and scalars and resolving vectors. Again, the students should already by right be well versed with this topic. However, if they need a revision on that, you can always go through it once more. But yeah, the new information would be pretty much these 4 topics, and they need to use this in the exam. So yeah, that pretty much sums up this topic.